When we see a function notation, we often think that a function is a single specific value. However, this is not always the case. A function can be a set of values, or a rule that produces a set of values. For example, the function f of x equals 2 to x to the power of 2 plus 1 can be thought of as a set of ordered pairs 0, 1, 1, 2, 2, 5, 3, 10, 4, 17, and so on. Or we can think of it as a rule that produces a set of ordered pairs. For any x, the function f of x produces the ordered pair x2 plus 1. Remember, a function is not always a single specific value. It can be a set of values, or a rule that produces a set of values. In mathematics, interval notation is a method of writing down a set of numbers which includes all numbers in a given interval. The interval can be defined using either the inclusive or exclusive form of the notation. Inclusive form means the interval includes both the endpoint values, while exclusive form means that the interval does not include the endpoint values. A common misconception about interval notation is that the endpoint values must be included in the interval. However, this is not always the case. In fact, endpoint values can be excluded from the interval if it is stated explicitly in the notation. For example, the interval 0, 1 can be read as the set of all numbers between 0 and 1, excluding 0 and 1. This can be a bit confusing at first, but once you get the hang of it, interval notation is a very powerful tool for working with sets of numbers.
Hey guys, in this video, we're going to talk about a common misconception about inverse functions. A lot of people think that the inverse of a function is just the function flipped over the y-axis, but that's not actually true. The inverse of a function is a function that undoes the original function. So, if we have a function f of x that takes us from x to y, then the inverse function f to the power of -1 of x takes us from y back to x. Make sense? Let's look at an example. Say we have the function f of x equals 2x plus 3. We can graph this on a coordinate plane. F of 1 equals 2 times 1 plus 3. That equals 5. So we can plot the point 1, 5 on our graph. F of 2 equals 2 times 2 plus 3. That equals 7. So we can plot the point 2, 7 on our graph. We can keep going until we have all of our points plotted. Now we can draw our inverse function. Remember, the inverse function takes us from y back to x. So we can start the point 0, 3, which is the point where y equals 3. We plot the point 3, 0, which is the point where x equals 3. Then we plot the point 2, -1, which is the point where x equals 2. We can keep going until we have all of our points plotted. As you can see, the inverse function is not the original function flipped over the y-axis. So, the next time someone tells you that the inverse of a function is just the function flipped over the y-axis, you can set them straight.